Hi, it's Make It Month 4 and this month we're looking at soldering. So soldering is the most common way of joining pieces of metal together. So for example, last month, Make It Month 3, we were looking at forming and we went over how to make sort of basic ring shapes, and although this looks like a ring, it's not actually joined together, it's just wrapped around, whereas normally a ring would be a solid thing that's joined together, so therefore you can't sort of adjust the size just by hand, things like that. It's a solid thing because it's been soldered together. So the way soldering works is you take whatever metal you're working with, so for example silver, and you get some silver solder, and the way they make silver solder is they take the silver and then they mix it with a lower melting temperature metal such as zinc. And therefore, when you heat this until this becomes liquid, you know this is going to melt before this will. There's 4 main types of silver solder. You get hard, which is this one, medium, easy, and extra easy. So the hard is mostly silver with a little bit of zinc mixed into it. The medium has a bit more zinc mixed in, the easy a bit more, and the extra easy has loads of zinc mixed into it. So each time they add zinc, it becomes easier and easier to melt the solder because it's a much lower melting temperature than the original silver. Because of that, a lot of people think, oh, why wouldn't I use extra easy for everything? Because it's much easier to melt, you're less likely to melt your actual work, things like that. But if you think about it, the more zinc they add into it, the less silver content's there, so the less pure it is, the less, it's not as good quality, it's not as strong, it's not as good a colour match. So therefore I use hard solder for pretty much everything because it's the purest. The way the soldering works, if you remember from Make It Month 3 example, this little wrapped ring, it's nice and springy, it holds its shape because I work hardened it. So work hardening was when you are hammering or twisting or bending your metal and its crystalline structure therefore gets bent and misaligned and jammed together and compressed, and it becomes hard and rigid. And then if you remember, we then annealed it. So annealing was where we applied the blowtorch heat until everything realigned internally and it became nice and soft and malleable again. But if you look at my fingers, when the crystalline structure realigns, it has all these gaps between it compared to when it's hard and compressed. Now those gaps we refer to as pores. So what happens is, if you heat everything until the solder melts, because the solder is going to melt quicker than this, if those pores are open, the molten solder can run into those pores. I always describe it like those face masks, which apparently only I wear because everyone thinks I'm crazy. But you go into the shower, have a hot shower, the pores of your skin opens up, you put the face mask on, the liquid face mask, it drops into those pores, you get out the shower, go to a cooler area, your pores of your skin contract, and that's what holds the mask in your pores. And then in the case of face masks, you then peel it off and you've got all those black heads to look out, which is gross. But believe it or not, similar concept. So you have your 2 sides of your metal, or your 2 pieces you're trying to join together. You heat them hot enough so that your solder runs and becomes liquid. Because the pores of the metal through the heat have opened up, that liquid solder runs into those pores, you take the heat away, the pores contract, and that's what's holding it all together. So because it's a liquid running into the open structure of your silver, the pores, there's a few things you have to do to get it to work. One of the most important things you have to do to get it to work is have a nice tight join to begin with. So if you imagine that the reason it's working is because the 2 pieces of metal are hot enough that the pores open up, you get it hot enough so that the solder turns liquid and melts. If you've got a gap, that liquid can only drop into the pores of the side of the pieces of silver that it's touching the most, because it's not, it's a liquid, it's not going to sort of suddenly jump up and fill a big gap. So it needs to be a nice tight join. That's one of the big things. The other thing is solder likes to run towards the heat. So it's the heat of the metal that melts the solder. So it's important that both elements you're joining together are the same temperature, that we judge by the colour that they go. Because otherwise, if one bit's hotter than another bit, the solder is just going to run onto the hottest side and not join. To demonstrate the soldering, I've bent a piece of silver wire into a rough ring shape, measured it around my finger to make sure it will fit. I'm going to do a separate demo on step by step of how to make a ring, but the important part here is that the join is nice and tight. There's no gaps in between it, because if you remember, if there's a gap, then the solder's only going to run onto the side that is closest to. Nice tight join, which means that the solder can run onto both sides if I get the heat right. So, like I said, I'm going to demo with this. We're going to move over there to the soldering setup and I'll show you what to do next. We had a look at the basic tools last month. So if you remember, one of them was a soldering brick. So it's really important that you have a surface to do your soldering on that is suitable for the heat. It can't be a normal household brick or a breeze block because they contain air pockets, and when you go in with the heat of the blowtorch, that air pocket could expand and it could, you know, explode, which you do not want. So it's a proper soldering block. And the extra thing that we didn't have last month is flux. Now, if you remember when we were doing the annealing, because we're using a gas flame, the gas mixes with the oxygen and it causes oxides on your metal. Now those black oxides are dirt at the end of the day, and if that dirt is on the metal that you're trying to join together, it's going to stop the soldering from being able to flow. So therefore we need some flux to keep it clean. Flux is a generic term, a bit like saying vacuum cleaner, and then you get lots of different types, lots of different brands. So the one that we're going to be using is borax. Borax is a mineral. I dropped mine. It was split in half. But it's a mineral. It comes in a cone format normally. You can also get it as powder. And what you do is you wet it and pop it in some water, put it into a borax dish. So this is just a ceramic dish, and then you grind it into a paste. So I'm just going to sit and do this for a minute now. You're looking for a creamy consistency, and that's what you're going to paint onto your metal. The way the flux works is it absorbs the oxygen, and by absorbing the oxygen, the oxides can't form in that area. One of the areas where soldering can be a bit confusing is if you look at most videos online, if you read most books and tutorials, they will say one of the most important things is that there is no dirt or contamination on your silver or your flux or your solder or anything that you're using. So therefore you have to go through all these various ways of cleaning your join and making sure that your flux is pristine and your solder is pristine, otherwise it won't work. In my opinion, I've never ever had an issue from that. The only extreme would be if your piece of jewellery you're trying to solder together is absolutely filthy. So for example, it's absolutely covered in oxides and you haven't cleaned it and you try and solder it, yes, that could be an issue. If we're just talking about handling it in general dirt from the workshop, or you can see how dirty my flux is, I don't find it causes the slightest bit of difference, so I'm not going to bother cleaning it. I'm just going to take my paintbrush, pick up the flux and paint it around the join. I've not opened the join up, I've literally just painted the flux where I want the solder to run. So on both sides of that join. I'm not going to paint the whole thing either. Some people paint the entire piece because they want to stop the oxides getting the silver dirty. But I'm just going to paint the join because in theory wherever you paint the flux, the solder could run. The next thing I'm going to do is I'm going to take my hard solder and I'm going to cut a tiny amount. So it's called a pallion. And the way to make it easier is to cut a fringe on it, cut it lengthways, like so. I'll just squish that together, and now I can cut a tiny bit, ping it across the room, tiny bit into there. Tiny bit of solder on the brick. I'm going to pick my ring up and I'm going to stick the join directly on top of that solder, so the solder is sat underneath the join. Now, like I mentioned earlier, solder wants to run towards the heat. So if I'm heating from above and the solder is underneath, it's going to want to run upwards. And also because I've got a really tight join, it's going to want to run upwards due to capillary action. It's going to want to get sucked up that join. For some reason, most people will tell you and show you to put the solder on top or buttered up against the front. If you do that, not only is the solder more likely just to spread everywhere rather than go exactly where you want it up the joint, you're more likely to blow it away, because in a minute when we light the blowtorch and go near this, the water that I mixed into that flux is going to boil and evaporate, and that could knock my solder out of position. But at the minute, it's pinned under the ring. Right, I've got my safety goggles on, I've got a clear space around here. I'm going to light my torch. And then, like I say, because the solder wants to run towards the heat, I'm going to heat it evenly either side of this joint. The first thing that will happen is the water that I mix in the flux is going to evaporate, so the flux will probably go white and crusty and a bit bubbly. The next thing that will happen is the flux will go clear and more glassy, and that's it telling me that the solder is almost hot enough to melt and run. So now I'm doing a little wiggle up and down my joint, and it ran, so I've taken the heat off. Quick as that. I'm going to pick it up with some tweezers, quench it in the cold water, and now it's solid and joined. There you go. So you can see here it's joined, and then you can also see the most of the ring has gone all blacky grey with those oxides, and then the section that I covered with the flux isn't blacky grey. So it's changed colour slightly with the heat, but it doesn't have that dirt on there in the same way. And then in the middle you can see where the solders run all the way around. So now we need to clean that, and the way you normally clean it is with sodium biosulfate. So I'm going to put this in here. Sodium biosulfate is normally called safety pickle. It's a really mild salt-based acid, and it's just going to eat away all that black colour. I've got mine in a little plastic tea strainer to make it easy to fish things in and out, and it works a lot quicker if the solutions are warm. The safety pickle gets contaminated if you put anything steel into the solution, so when we're fishing things in and out, we don't want to be using any of the normal steel tools or tweezers. You hear quite a lot of talk about, I don't know if it's an American thing, where they say you must use copper tweezers. You can use pretty much any tweezers you want as long as they're not steel. So you can use plastic ones, brass ones, these are brass, copper, wood, whatever you would rather, as long as it's not steel. And it's ready to come out when it's nice and clean. So when all those black oxides have gone, you can fish it out, put it in some water, because although it is mild, at the end of the day it's an acid, so you want to wash it off. And then dry your piece off as well, because if your metal is wet and you put it on your steel tools, it's going to cause everything to rust. So make sure it's nice and dry. So hopefully you can see here, I've now got a nice neat join, neat solder join, tiny little bit of excess solder, which I'm going to need to file off, which I'll do in a second, but it's soldered in one piece, nice and neat. There you go, it's had a quick file and sand to start to hide the join. Still needs a little bit more work, but it's just a really quick demo that by using the right amount of solder and not having a gap, you should be able to create something that looks like a solid piece and you can't tell where the join is.